In this tutorial, we will review repeated measures ANOVA. Repeated measures ANOVA is useful for testing whether two or more groups changed differently over time. For example, does the treatment group show a larger change than the control group in the number of books read from pre-test to post-test? Begin by clicking the Analyze menu and selecting General Linear Model and Repeated Measures. The within subjects factor is time, meaning that all participants completed the same measure at 2 time points, thus the name repeated measures. We can label this factor as time and indicate that there are 2 levels or time points, pre and post. Add this to the box below and then click Define. In the next dialog box, you must specify which variables are your outcome measures in the box that says within subject variables. In this case, books pre and books post. The between subjects factor is group, meaning treatment versus control group. Click the Options button and select Descriptive Statistics. Then Continue. Then click the Plots button and select Time as the horizontal axis variable and Group as the separate lines variable. Add to the box below and then click Continue. Click OK and the output window occurs. As with the factorial ANOVA, the first 2 boxes simply summarize which variables were used and how many participants were in each condition. The third box presents descriptive statistics. For our purposes, we skip the boxes labeled multivariate tests and Mauchly's test of sphericity. The next box of interest is tests of within subjects effects. In a repeated measures ANOVA of this sort, we're really only interested in the main effect of time, meaning whether the entire sample changed from pre-test to post-test, and the interaction of time and group, meaning whether the 2 groups changed different amounts. The main effect of group, below, is somewhat irrelevant, as it tells us just whether the treatment and control groups differed in the number of books they read on average, not considering change from pre to post. In a study where we're interested in change, this test is not important. Therefore, we look at the 2 F tests in the within subjects effects box. The first F value for main effect of time is 83.83, which is significant at less than 0.001. Degrees of freedom are 1 and 38. This means that the mean pre-test score for the entire sample was different from the mean post-test score for the entire sample. However, the F value for the interaction of time and group, 71.87, is also significant at p less than 0.001. Degrees of freedom are 1 and 38. This means that although the overall sample means changed from pre and post, the 2 groups differed in terms of the amount of change. Indeed, an inspection of the plot below shows that the treatment group, the green line, increased substantially, whereas the control group, the blue line, appears not to have changed almost at all. Thus, it would be misleading to say that the sample as a whole changed from pre to post-test, when in fact only the treatment group changed. Incidentally, this is exactly the kind of outcome that we hope to see in an intervention study. The treatment group improves on the outcome of interest, and the control group stays roughly the same. Note that although the plot and an inspection of the means, control pre and post versus treatment pre and post, make it pretty obvious where the significant differences are in this example, this is not always the case. Thus, it is important to split the file by group and follow up the main analyses with paired t-tests, just as we followed up the factorial ANOVA with independent t-tests. The reason for using paired t-tests is that we have pre-test and post-test data from the same subjects. So, we go to Data, Split File, Compare Groups. In this case, we want to remove gender and instead compare by group. Click OK. Then we go to Analyze, Compare Means, Paired Samples t-test. We already have entered books pre and books post from a previous analysis. So we click OK. And as you can see, just as suspected, this t-test for a comparison of pre and post data for the control group was not significant, whereas a comparison of pre and post data for the treatment group is significant. The treatment group changed from a mean of 3.2 books to 7.1 books, whereas the control group changed only from 3.55 books to 3.70 books. We now have statistical evidence that the two groups differed in terms of the number of books read over time. This concludes our tutorial.